So this is the question number 7th of exercise 6.2. ABC is a triangle. We have to prove that the line drawn from the midpoint of one side parallel to another side bisects the third side. And this is the converse of midpoint theorem that we had studied last year. Okay? So line drawn from the midpoint of one side parallel to another side bisects the third side. What we have been given, D is the midpoint of AB. Midpoint से draw की जा रही है. And DE is parallel to BC. प्रूव क्या करना है? That E is also a midpoint. ठीक है? अब लास्ट ईयर इसका बड़ा कॉम्प्लिकेटेड प्रूफ था, इस बार ऐसा कुछ नहीं है, सीधे प्रूफ पर चलते हैं. DE is parallel to BC. गिवन है. फाइन. सो AD upon DB is equals to AE upon EC by BPT. Quite easy. Am I right? AD upon DB is equals to AE upon EC. But AD is equals to DB given है. So AD को हटाकर I can write as DB upon DB is equals to AE upon EC. AD को I have removed and in place of AD I have written DB. Question नहीं कहा हुआ है D is the midpoint. ठीक है? So both of these gets cancelled. I am getting 1. If I cross multiply, EC is equals to AE, or E is midpoint of AC. Hence proved. This is the next question. Question number 8. ये midpoint theorem है जो class 9th में पढ़ी थी. What is that? The line segment joining the midpoints of two sides is parallel to the third side. This is what we are supposed to prove. Both of them are given as midpoints. So D is the midpoint of AB and E is the midpoint of AC. ठीक है? Prove क्या करना है? That DE is parallel to BC. Fine. Proof. AD is equals to DB. Given. कहाँ गिवन है? D is the midpoint. अगर D midpoint था तो AD किसके इक्वल है? DB के इक्वल है. So AD upon DB will be equals to 1. दोनों साइड DB से डिवाइड कर दिया. क्या किया? What we have done? We have divided both the sides by DB. So AD upon DB, DB upon DB comes out to be 1. Number 1 equation. Similarly, we have been given that E is the midpoint of AC. Again, we have been given the same thing. AE is equals to EC. E is the midpoint of AC. So, AE upon EC will be equals to 1. दोनों साइड कैसे डिवाइड कर दिया? EC से डिवाइड कर दिया. From 1 and 2, from 1 and 2, AD upon DB is equals to AE upon EC. कहा जा सकता है. Now, what was the converse of BPT? If a line divides the two sides of a triangle in the same ratio, then the line is parallel to the third side. Converse of BPT यही था. Fine. So, if a line divides the two sides of a triangle in the same ratio, then the line is parallel to the third side by converse of BPT. Hence proved. Before we proceed for the next question, we need to understand some properties of ratio and proportion. If A upon B is equals to C upon D, means whenever two ratios are equal, then obviously their reciprocals will also be equal. Ayana? If I reciprocate both the sides, their reciprocals will also be equal. This process is called as invertendo. What it is called as? Invertendo. ठीक है? If any one of the diagonal pair is exchanged. यानी कि if I exchange A or D and if I exchange B or C, either one of them. ठीक है? So if I write it as A upon C is equals to B upon D, the relation holds true. क्रॉस मल्टीप्लाई करेंगे AD इक्वल टू BC आ रहा है, इसको भी क्रॉस मल्टीप्लाई करेंगे AD इक्वल टू BC आ रहा है. Yes or no? But this process is called as alternando. What it is called as? Alternando. Fine. Reciprocal both the sides, invertendo. One pair of diagonal exchanged, alternando. ठीक है? Add one both sides, componendo. Subtract one both sides, dividendo. And इसी को मर्ज कर दिया जाए, that is componendo and dividendo. ये 11th 12th में बहुत काम आता है. ठीक है? If I add one both the sides means A plus B upon B is equals to C plus D upon D. सोच के देखो, वन ऐड किया, LCM लेंगे, B LCM आएगा, A plus B upon B बनेगा. This process is called as component. And if I subtract one both sides, the same thing will become, this is called as dividendo. और अगर इन दोनों को आपस में डिवाइड कर दिया जाए, then I get A plus B upon A minus B, C plus D upon C minus D. This is called as componendo and dividendo. तो ये कुछ प्रोसेसेस हैं जो किस पर काम करते हैं, रेशियोज पर, and we are going to use them in the next question. That's why it was necessary to explain these processes first of all. We'll be using this one in the next question, alternando. So moving on to the next question, we have been given in this question that ABCD is a trapezium in which AB and DC are parallel. So you can see that I have marked the arrows with pink color, that AB is parallel to DC. Fine. And diagonals AC and BD intersect at point O. We have to prove that AO upon BO is equals to CO upon DO. In order to prove this one, we have to have a construction, and that is draw OE parallel to AB, and since it is parallel to AB, it is automatically parallel to DC as well, because AB and DC are also parallel. That means in this question, we have a set of 3 lines becoming parallel. Okay? Proof. Now, we have to apply BPT. Again, in order to apply BPT, I need a pair of parallel lines. If I consider these 2 parallel lines, then the triangle which I can take is BDC. So in triangle BDC, OE is parallel to DC. Just focus on this particular triangle. कौन सा triangle की बात कर रहा हूँ? Triangle BDC. In this triangle, OE is parallel to DC. So if I apply BPT, what I'll be writing as BO upon DO is equals to BE upon EC या CE. Same fashion में रखो, better. By BPT, let us mark it as equation number 1. Okay, fine. Then which 2 parallel lines I have taken? These 2. Now, if I consider these 2 parallel lines, and if I choose this particular triangle for BPT, can it be taken? Okay. So in triangle ABC, OE is parallel to AB. Now see, take care that I'll be writing in the same fashion जो मैंने यहाँ लिखा है. ठीक है? So what I'll be writing it as AO upon CO is equals to BE upon CE by BPT again, and that is equation number 2. ठीक है. If I compare first and second, the RHS of both of them are same. ठीक है, दोनों का RHS क्या है? Same. So from 1 and 2, AO upon BO upon DO is equals to AO upon CO. But this is not what we are supposed to prove. ठीक है, so वो लाने के लिए मुझे क्या करना पड़ेगा? I need to exchange this pair of terms. So using alternando. Using alternando, CO ऊपर आ जाएगा upon DO is equals to AO upon BO. Hence proved. ठीक है. So first of all, I took the triangle BDC. I applied BPT. Then I took the triangle ABC and I applied BPT again. I got one of the sides equal. दूसरी साइड equal आ गई. उस पर क्या लगाया? Alternando. I have got the result. Although यही same question अगली एक्सरसाइज में हम सिमिलैरिटी से सॉल्व करेंगे. किससे? We'll solve it by similarity. उसमें कोई जरूरत ही नहीं है बीपीटी की. अगर इस क्वेश्चन को करते वक्त स्पेसिफिकली क्वेश्चन में मेंशन्ड हो that use BPT to solve this question, तब आपको ऐसे करना है. अगर सिंपली ये क्वेश्चन सॉल्व करने को आए, then we'll be solving it by similarity. अभी समझाता हूं कैसे. एक बार पहले इसको कॉपी करो. So this same question is being given again in next exercise 6.3, and that is question number 3. But this time we are not going to use BPT in solving this question. So what are we known of? That AB and DC are parallel, and this is what we are supposed to prove. If these two lines are parallel, then this becomes a transversal. Am I right? So if this is a transversal, then angle 1 is equals to angle 2. Am I right? Fine. Similarly, this also becomes a transversal. That means these two angles are also equal. Fine. And both of these angles are vertically opposite angles. So they are also equal. So now I can write in this one that in triangle AOB and triangle COD, angle 1 is equals to angle 2 and angle 3 is equals to angle 4. They both are using the same property, alternate interior angles. And angle AOB is equals to angle COD by vertically opposite angles. Fine. So if all the angles of one triangle are respectively equal to all the angles of another triangle, then both the triangles are similar. So अगर मैं यहाँ से देखूं तो triangle AOB is similar to triangle AOB. So what you will be writing? A के equal कौन था? COD. Triangle COD by triple A. हालांकि हमारा काम दो एंगल से भी चल जाता है, तो अगर आप यहाँ पर केवल दो एंगल्स भी लेते then it would have been sufficient. Fine. अब यहां से देखें, if I write AO, then what I'll be writing from here? CO. And if I'm writing BO, then I'll be writing DO. कहां से? By similarity. जैसे आप congruency में करते थे, वैसे ही यहां पर होगा. Whatever you have taken from here, AO, the same thing will come in denominator, but from the other triangle, CO. Then BO, then from here, DO. Again, if I use alternando, then I'll get same thing. AO upon BO is equals to CO upon DO. This becomes a quite easy method as compared to the previous one, but the previous one was using BPT and this is using similarity. So if the question doesn't say anything, then you have to go by this method. And if the question specifies that using BPT, then you have no choice but to go with the first one. ठीक है?